Okay guys, today we are going to be looking at calculating pH and pOH as well as hydrogen ion and hydroxide ion concentration. And so you're going to watch this video, and I'm also going to show you how to do those on a scientific calculator that I have found online. And then you're going to be, we're going to do some practice problems on a quiz, and then you're going to have a quiz to do on your own as well. And then the last thing that we'll do in this unit is we will talk a little bit about titrations. Now, if we were in class, we would actually do 2 or 3 of these, and your final, like your second 9 weeks test would actually be a titration, where we would do the lab and then you would get an answer, and if your answer was within 10% of what the correct answer actually was, then you would get 100 on your second 9 weeks test. But since we're not in class, you're going to watch a video about how to do a titration, and then we're going to look at how to do calculations associated with titrations. And so that will be tomorrow and Wednesday, and then planning on having a test over acids and bases by the end of the week. So these lesson plans have been posted on Google Classroom. You can go and look at those if you want to. So what we want to look at today then are calculations dealing with pH and pOH. pH is basically a measure of the hydrogen ion or hydronium ion concentration in a solution. So when we're looking at pH, we're really looking at the hydrogen ion concentration. And remember, the H3O plus is the hydronium ion, and that is water that has a hydrogen ion added. So we use these interchangeably. So when we are looking at the pH, we're looking at the hydrogen ion concentration, which is a measure of the acidity of a solution. And to calculate it, we're going to use this formula right here, and this is why we have to have a scientific calculator. The pH is equal to the negative log of the hydrogen ion concentration. So if you have the hydrogen ion concentration, you can find the pH. Again, different scientific calculators, you have to go through a different sequence of pressing buttons to do the negative log of the hydrogen ion concentration, which a lot of times is in scientific notation. So it may be like 2.5 times 10 to the negative 3. So in addition to getting the negative log, you've got to be able to punch in the 2.5 times 10 to the negative 3 and then do the negative log of that. And so anyway, different scientific calculators, you have to punch that in differently. So I found a scientific calculator online that I'm going to be using today. I will post the website for that on Google Classroom. It did ask me to accept cookies. So if you have a scientific calculator that you like to use, that you know how to use to punch in a formula like this, then by all means use your own. But all the scientific calculators, like the scientific calculator that I have as far as the like on my iPhone, you have to go through this whole series of punching in numbers, and you have to punch them in backward, and it's just crazy. So I found one online that's pretty easy to punch this formula into the calculator. So you can use it. As I said, it is going to ask you to accept cookies. So if you don't want to do that and you have a scientific calculator that you know how to use, then by all means use that. Just check and make sure that you are punching the numbers in and getting the correct answer, so that you won't miss the problems that I give you on the quiz or on the test that we'll be taking later on in the week. So anyway, to calculate the pH, you do the negative log of the hydrogen ion concentration, and we will do some problems like that here in a minute. On the other hand, if we are given the hydrogen ion concentration, we can, like I just said, we can determine the pH. But if we're given the pH, we can use the pH to determine the hydrogen ion concentration. So you're basically just taking this equation and you're flipping it around. If we have the hydrogen ion concentration, we can do negative log of the hydrogen ion concentration to get the pH. But if we have the pH, we can do 10 to the negative pH to get the hydrogen ion concentration. So, you can use those interchangeably. Furthermore, we can do the same thing with the pOH. When we're talking about pOH, we're talking about the concentration of hydroxide ions in a solution. And we're going to calculate pOH and pH the same way. For pH, it's the negative log of the hydrogen ion concentration. Well, for pOH, it's the negative log of the hydroxide ion concentration. So if we know the hydroxide ion concentration, then we can determine the pOH of the solution. Likewise, if we know the pOH of the solution, we can turn that formula around and we can calculate the hydroxide ion concentration. The hydroxide ion concentration is 10 to the negative pOH. Well, why do we care? Why do we care if we have the pH, we can get the hydrogen ion concentration. If we have the hydrogen ion concentration, we can get the pH. And especially, why in the world do we care if we have the hydroxide ion concentration, we can get the pOH, or if we have the pOH, we can get the hydroxide ion concentration. Well, there's a really neat thing here, guys. Water is neutral. Its pH is 7. So in water, the hydrogen ion and hydroxide ion concentration are equal. They're both equal to 10 to the negative 7. So therefore, when we take the hydrogen ion concentration times the hydroxide ion concentration, we get 10 to the negative 14. So we can basically say, okay, in any solution, the pH plus the pOH is equal to, and I don't have it on here, so I might type it on here. The pH plus the pOH is equal to 14. Okay? Likewise, the hydrogen ion concentration plus the hydroxide ion concentration, and I guess I need to make those capital, is equal to 10 to the negative 14. So therefore, we know that the pH plus the pOH added together is equal to 14. We also know that the hydrogen ion concentration plus the hydroxide ion concentration added together is equal to 10 to the negative 14. So what does this mean? This means that if we know one, we can find all the others, okay? If we know the pH is 3, we know the pH and the pOH added together is 14, then that tells me that, hey, if the pH is 3, the pOH has to be 11, okay? And if we know that, then we can find the hydrogen ion or the hydroxide ion concentration, and vice versa. If I know that the hydrogen ion concentration is 10 to the negative 3, 1 times 10 to the negative 3, then I know the hydroxide ion concentration has to be 1 times 10 to the negative 11. And so then I can use that to find the pH and the pOH. So knowing that the two added together gives me 14, or knowing that the two ion concentrations added together gives me 10 to the negative 14, allows me to have one piece of these 4 and find all the others, okay? So let's go ahead then and we're going to look at a quiz on quizzes, and we're actually going to have the answers there. I'm going to display the answers so that we can use these formulas to find answers to questions. So let's look at the first one here. If the hydrogen ion concentration of a solution is 1 times 10 to the negative 2, we want to know what the pH is. So what we need to do then, remember, pH is equal to negative log of the hydrogen ion concentration. So we need to do the negative log of 1 times 10 to the minus 2. So here is my scientific calculator that I'm going to be using. So all I have to do is type in negative log 1 times, and then I'm going to hit the 10 to the x, negative 2. And up here it shows me I'm doing the negative log of 1 times 10 to the minus 2 equals, and here's my answer, 2. So let's see if that's correct. And it is. That is correct. Okay? The next one. If the pH of a solution is 5, then the hydrogen ion concentration is. Well, if I know the pH, remember, I can find the hydrogen ion concentration by doing 10 to the negative pH. So I need to do 10 to the negative 5 here. So go back to my scientific calculator, clear, 10 to the x, 10 to the negative 5 equals. And this shows me that my answer is 0.00001. So in scientific notation, that would be 1 times 10 to the 1, 2, 3, 4, 5. 1 times 10 to the negative 5. Again, since I moved my decimal point over and made that a bigger number, then my exponent has to be negative. So this is 1 times 10 to the negative 5. So let's see if that's correct. 1 times 10 to the negative 5. Yes, it is correct. Let's go to the next one. If the pH of a solution is 5.6, then the pOH is. Well, remember that pH plus pOH is equal to 14. So then this means that the pOH is equal to 14 minus 5.6. So let's clear 14 minus 5.6. My answer should be 8.4. Let's see if that's correct. Yes, it is correct. Moving on. A pH and a pOH will add up to, I hope you remember the answer is 14 there. Yes. The next one, if the hydrogen ion concentration of a solution is 1 times 10 to the minus 2, then the pH is. Okay, to get the pH, remember we have to do the negative log of the hydrogen ion concentration. So we need to do the negative log of 1.0 times 10 to the minus 2. So make sure you clear. Negative log 1, what was it? 1.0 times 10 to the minus 2. 1.0 times 10 to the x, 10, that is 10 to the minus 2, equals. And we get 2. Is that correct? Yes, it is. Okay, moving on. If the hydronium ion, remember that's the same thing as hydrogen ion, of a solution is 1 times 10 to the minus 8, then the hydroxide ion must be what? Well, we know, remember that the hydrogen ion and hydroxide ion concentration added together has to be 1 times 10 to the minus 14. So 1 times 10 to the minus 8 subtracted from 1 times 10 to the minus 14 is 1 times 10 to the minus 6. See if that's correct. Yes, that is correct. Moving on. If the hydroxide ion concentration is 2.7 times 10 to the minus 4, then the pOH of the solution is. Okay, remember to get the pOH, we take the negative log of the hydroxide ion concentration. So we need to do the negative log of 2.7 times 10 to the minus 4. So clear first, make sure you clear. Negative log, and then what was my problem again? 2.7 times 10 to the minus 4. Negative log of 2.7 times 10 to the x, and my x is minus 4, equals. And I have 3.61, 3.62. So let's look and see. 3.56 is the closest one. That is correct. Okay. Next one. If the pH of a solution is 7, then the solution is said to be, I hope you said, neutral. And that is correct. Moving on. A solution with a hydrogen ion concentration of 9.4 times 10 to the minus 5 is said to be, well, is it acidic, neutral, basic, or a negative number? Well, how do we know what the pH is? In order to know if it's acidic, neutral, or basic, we have to determine the pH. Well, how do we get the pH if we have the hydrogen ion concentration? We do negative log of the hydrogen ion concentration. So we need to do negative log of 9.4 times 10 to the minus 5. So clear, negative log 9.4 times 10 to the x minus 5 equals. And it looks like it is 4.02. Well, we know that anything under 7 is acidic. Above 7 is basic, under 7 is acidic. So this solution has a pH of 4.02, so this means this solution is acidic. Let's see if we're correct. Yes, we are. Moving on. If the hydrogen ion concentration of a solution is 6.8 times 10 to the minus 9, then the pH is. Again, to get the pH, we do the negative log of the hydrogen ion concentration. The hydrogen ion concentration here is 6.8 times 10 to the minus 9, so we need to do negative log of 6.8 times 10 to the minus 9. So clear. Negative log 10.8 times, wait a minute, I think I did that wrong. 6.8 times 10 to the minus 9. Let me do that again. Negative log 6.8 times 10 to the x minus 9 equals. And we get 8.17. So it looks like it's probably going to be this one right here. Show the answer. It is 8.17. Next, if the hydrogen ion of a solution, if the hydrogen ion concentration of a solution is 8.4 times 10 to the minus 3, then the pOH of the solution will be. Well, if I have the hydrogen ion concentration, I could find the pH, right? And then if I know the pH, then I know the pH plus the pOH equals 14. So to get the answer to the pOH here, I'm going to have to find the pH by doing the negative log of 8.4 times 10 to the minus 3. Once I have the pH, I can subtract that from 14, and that will give me the pOH. So the first thing I need to do here is 8.4 negative log of 8.4 times 10 to the minus 3. So clear, negative log 8.4 times 10 to the x minus 3 equals. Okay, so now I know my pH is 2.07 or 2.08. So if the pH is 2.07 or 2.08, I know that the pH plus the pOH equals 14. So then my answer of the pOH would be 14 minus this 2.0, let's say 8. So clear it again, 14 minus 2.08 equals. And I get 11.92. So it looks like this would be the answer. And we are correct. Next, if a solution has a pOH of 5.2, then the hydroxide ion concentration of the solution would be. Okay, remember, if I know the pOH, I can do 10 to the negative pOH to get the hydroxide ion concentration. So I need to do 10 to the negative 5.2. So 10 to the x, wait a minute, let's clear it first. 10 to the x negative 5.2 equals. And I'm getting, again, I'm going to have a negative exponent here. 1, 2, 3, 4, 5, 6. So I'm getting 6.3 times 10 to the minus 6. Now, when this is what I would say the answer is, but when I look at the answer here, I think they have the wrong answer marked. I think the answer should be 6.3 times 10 to the minus 6 for this one. I don't know why. I think whoever made this quiz, because I did not make this quiz, someone else did. So I think whoever made this quiz just messed up on the answer. I think this would be the correct answer. Okay. Next question. Limes have a hydronium ion, which is, remember, hydrogen ions, concentration of 1.3 times 10 to the minus 2. Their pOH is, okay, this is just like the other one that we did a few minutes ago. If we have the hydrogen ion concentration, we can do the negative log of this hydrogen ion concentration to get the pH, and then we can subtract that from 14 to get the pOH. So the first thing we need to do then is do the negative log of 1.3 times 10 to the minus 2. So clear, negative log 1.3 times 10 to the x minus 2 equals. And I'm getting 1.89. Okay, so the pH is 1.89, but I want the pOH. This is what I just calculated was the pH because this is the hydrogen ion concentration. So when I do the negative log of the hydrogen ion concentration, I'm getting the pH. They're asking me for the pOH, so I have to take that pH and subtract it from 14. So my pH is 1.89, so I'm going to have to do 14 minus 1.89, and I get 12.11. And so this should be my answer, and that is correct. All right, and that is the last practice problem that I have. So again, you're going to have a quiz similar to this with similar problems, and you're going to use either this web-based scientific calculator that I found, which again I have posted this calculator on Google Classroom for you to use, or else use your own scientific calculator if you know how to punch in these exponents and these 10 to the negatives and these negative logs correctly. Otherwise, you can, again, do just exactly like what I did in this video to get the answers to the questions on your quizzes. And I will probably give you on your questions probably like maybe, a minute or two to answer the questions before it cuts off for you. I'm also going to set the quiz again so that it will let you take the quiz as many times as you want. So that way I don't know if it keeps up with the highest grade that you made or if it changes your grade every time, but whatever your grade is when this quiz shuts off, next Sunday, the 26th of April at 11:45 p.m. is when it will shut off. So whatever your score is, when this quiz shuts off and you can't take it anymore, that is the score that I'll put in Infinite Campus for you. Please let me know if you have any questions. I hope you have a great day and a great week. We'll talk to you later. Bye-bye.